In this session, we will learn how to develop dynamic link library for Scilab using Visual Studio. We will understand the structure of the Scilab Gateway library, and then create a DLL project for the library in Visual Studio. Dynamic link library files are used to share functions, and provide systematic way to arrange and manage code which can be reused by various applications. Now, here we will understand the structure of the library which we want to develop. We know that Scilab engine connects with our external function using gateway function. For this, we need to define few basic files for our library in Visual Studio. These files are created automatically by the Scilab build function when we compile our function in Scilab. In the DLL, libmod header and CPP files contain routines to add the gateway function to the Scilab engine. It has a special macro to connect the gateway function to Scilab, called cGatewayPrototype. Using this macro, the gateway function is registered inside the Scilab engine. Then we create the files which contain native C or C++ function, which we want to use in Scilab, and connect it with the gateway function. This way, all the files are interconnected and the library is compiled. Now, we take a simple example to develop an external function library in Visual Studio, for calculating sectional properties of arbitrary polygons. We have already developed the GUI for displaying the polygon, and now, we will develop the function to calculate area, center of mass and moment of inertia for the 2D polygonal shapes. We will start with setting up the Win32 DLL project in Visual Studio, and add all necessary references for header files and library files, so that we can use the Scilab API functions. We will define module definition files, gateway function, and section calculator function in the DLL and connect to Scilab. Now, we look at the files which we need to define in our library. Module files will have the entry point function which will help the library to connect to Scilab, and connect the gateway function to Scilab. Our gateway function will have all the required Scilab API functions, to receive data and send it to our native function, and return results to Scilab. We define a class named CINGPoly, which will have functions to calculate the section properties like area, center of mass and moment of inertia. Now, in our CINGPoly class, we implement these functions to calculate area, centroid, and moment of inertia of the 2D polygon. Now let's start Visual Studio and develop our polygon library. Now, we start Visual Studio Community Edition, and create a new project. Then, we select the Dynamic Link Library project, and specify the project name and path. Now, first we change the project configuration from 32-bit to 64-bit. Then from Project menu, we open the Properties window. In the compiler section, we will provide paths for all the header files for Scilab API library, which is available in Modules folder of the Scilab installation directory. Then, in Linker section, we will add the path of bin folder which contains all the referenced Scilab API library files. And in the Linker input section, we will specify the names of the library files, which we are using in this project. Now, we add new project files, using Add New Items menu. we add the header and implementation files for our module, gateway, and native functions. Now, we will discuss the code which we need to write. In the module header file, we first define the symbols to export and import functions from DLL files. Then we define a function called libpoly, which is the entry point function of our library file. In the source code file, we define the body of our function. In this function, we use addC function, which is an API function of Scilab, used for adding our custom function address to Scilab engine. Using this function, we are connecting our gateway function to Scilab. Now, in the gateway header file, we use the cGateway prototype macro to define our gateway function and connect it to Scilab. The gateway function is defined in the same way as we had done earlier. First, we define variables and pointers, which are used in the function. Then, we verify the number of arguments passed. Then, using the API functions, we extract the x and y coordinates array data from the input arguments. Then, we pass the data to our polygon calculator class to calculate the sectional properties of the polygon. Then, using the API functions, we create output variables and pass the results of the calculation back to Scilab. We define our polygon section calculator class, CING_poly, as a regular C++ class. We define variables and functions required to implement the calculations. In the source file, we implement the formulas to calculate the area, centroid, and moment of inertia of the polygon. After compiling the library, we copy the polysect DLL file in the working directory, and load it using the loader script. Then, as we saw in our earlier Polygon GUI session, we use the polysect function as a normal Scilab function, and calculate the properties of the polygon. In this way, we can use our C or C++ functions in Scilab, using its API functions. That brings us to the end of this session. Thank you for your interest and attention.